Hello, hello, hello. Welcome to the stream. Let's see here. I think I got the right microphone selected. Audio sound good? We had a bunch of issues with the microphone last time. Well, really we had a bunch of issues with just the generality of USB ports, but welcome to the stream, Greg. Good to see you. Oh, I just realized I forgot to post a link to Mastodon, so I'm going to do that real quick. How are we all doing tonight? Well, welcome to the Nanographs post-game microscope live stream. I learned the game was happening today, so I could see people in the bar across the street from me watching it, though. So I was like, oh, it is happening. Let's see here. Let's get this on Mastodon. I'm not sure. I have not seen the Bad Bunny show, so probably not, given that they're a world-renowned artist with millions of dollars in a production budget, and I'm wrenching on a microscope. So I can probably zoom in further. Well, not on that one right now. This one, sure. That one I can. But I could do a lot with that budget. I could do a lot with a lot less than that budget. I could build a lot of open source microscopes with that budget. Okay. Well, shall we? I think we're where we want to be. Okay, let's figure out what we're doing tonight. That's going to start with one of these ones, not that one. No, well, that camera should be turned on. Hey, there we go. Okay, cool. Okay. Oh, we need to do the chat thing. I have to set the thing correctly. I'm like a little bit annoyed you can't just like use one URL anymore. You have to do like a different URL every time now. And if I copy it from the wrong window, then it's like, oh, this isn't. You can't see this. This isn't the right chat. So I have to go to like a different live stream, and then pop out the chat from there, and then copy that URL. And there has got to be a better way of doing this, because this is annoying. But you know what? I don't have a better way set up right now, so we're just going to keep doing it this way. Okay, property URL. Paste that. Hey, look. Welcome to the stream, chat. Okay, so we got chat in here, which is what we want, and then okay, so let's reorder this list a little bit. So this list is everything, right? This is like everything that we've got left to do. We just want, for now, we just want to see what we're going to work on tonight. So let's see here. So we're not doing bake out, we're not doing utilities. I'm pretty much just going to do our electronics inspection. I'm probably not going to do high voltage tonight either. Okay, I think that represents. Well, this is I'm probably not going to get to all of this tonight, but this is what we're working on. So, dynamic optics driver, static optics driver. I mean, they're not. It's not really static, but you know, it's kind of referred to that as. So the dynamic optics are like our scan coils, right? They're moving very quickly, constantly, because it's a scanning electron microscope. The static optics drivers are like the objective lenses, or lens, condenser lens, stigmator. You could, source alignment coils are technically a dynamic optic driver, but they're actually really slow. Like it does actually scan the source alignment coils, which is kind of interesting, but it does so really slowly. So it's done using much lower speed electronics. So it's kind of considered just like a static optic that can kind of move quickly. So as far as where this is on the microscope, it is this down here. That is our dynamic optics driver right there. It's actually what the thumbnail of this live stream is. And it's already opened up for us. So yeah, I think it's time to start rearranging some lighting so that we can take a closer look at it. Come on. There we go. Now I got this one backwards. Let me fix that real quick. All of the illumination. Why did this get weird? It's supposed to be up here like this. There we go. Okay. So there's a lot of lighting. I do like my fancy lighting rig quite a bit. It works out very well, I think. Let's see here. What view do we want to run? That's usually a good one. Why is it being weird? It's probably being weird because I didn't duplicate that right. So let me. Hello, welcome to the stream. Mianochroma, or aka Monochroma, one of the two. Okay, let's change the width of that. Nope, wrong. Okay, so this is going to be HackMD wide. And then we're going to duplicate that, and we're going to make HackMD narrow. I guess you can't duplicate, I guess you can just copy. So copy and paste that. I don't know which one I pasted, so we're going to make that one HackMD wide 1. And wait, what? It uses... That's weird. Copy logic on OBS is not what you would expect. Wow. I don't like that. So if you copy something, and then you change the thing you copied, and then you paste it, it pastes it with the changes you made after you copied it. Why? Okay. So I'm trying to, I'm just going to add a new one. And that's going to work better. So we're going to do new browser source, create new, HackMD narrow. Cool. I just added a browser source, y'all. Isn't that exciting? So why are we going through all this work? It's because I want to have two different ones of the same thing so that when I use this other screen, it keeps that the same size instead of because it was like using like the same browser source between this scene and whatever scene I was on, which is one of these scenes. I don't know. Yeah, this one probably. So I've created another one. There we go. Okay. And then I need to get you all a link where you can edit. And furthermore, I need to make it so that you actually can edit. Great. Chat in OBS is broken. This is great. Why? How is it not signed into chat in OBS and I'm streaming? That shouldn't be possible. Okay, that's fine. We'll just chat from the browser. Ta-da! You have a link. Okay. Okay, I think we got it. I think we finally got it. We'll learn what I'm missing in a second. So for something fun to note, You may notice that my floor is substantially more shiny this time. You can see more of the microscope's reflection. Well, you can see it if the camera would focus correctly. There we go. So that's fun. That was a really quick floor maintenance session. Finally got the tools and procedures down to knock out polishing the floor really quickly, so that's fun. Okay, oh, I gotta remember to strain relief this cable properly so that we don't accidentally unplug y'all. So I'll get that done before I move the cameras all around. Okay, let's bring her on in. And of course the Logitech camera is not going to behave correctly until I open up Logitune. And then the second I open up the camera, all the controls are going to reset themselves, and then the exposure will work correctly, probably. Probably? Maybe? I'm pretty sure it's a shiny floor, not an alternate universe, but you never know these days. Okay, there we go. So, what are y'all up to tonight? Any fun projects? Yeah, I've got to make sure it's not the evil alternate universe version of myself. It's gonna be one of those episodes of Star Trek. Okay, so I'm just getting my photo stuff opened up because we're going to need that shortly, but we're not going to quite start with that. I'm also going to grab the 35mm macro lens, because I'm pretty sure we're going to start with that. So I'm going to go ahead and throw that on the camera. Oh man, you'll get there. Wonder how the camera feels about me doing lens changes while it's turned on still. I mean, it's a mirrorless camera, so like theoretically I could close the shutter. I still could close the shutter, but I don't know. I like the transition effect. Okay, so we got a macro on. Let's dig in. Yeah, I think we're pretty much ready. Let's see here. Okay, what's our plan? We've already got some external pictures of it. We'll get some pictures of it with the way it is right now. We do not know yet if the optical drive circuits are spicy or not. We are about to find out, though. What they are is out of focus at the moment because it is a manual focus. There we go. Also, welcome to the stream. Happy to see that your Zeiss is doing things. I think you'll be curious to see what the optics look like on this one. They're a little bit different than on your microscope. Okay, glad to have the bottle of Tums ready. We'll find out. I think, how many volts goes to the optics on this one? It says on the power supply. I think these are only 48. Oh, it's only 24. Interesting. Interesting. I thought the scan coils needed more voltage on this one than that. Maybe there's a buck or a boost, but that'd be unlikely because you want like more stable voltage than that for scan coils. I'm gonna trip over this. I need to fix that. Oh, that is tangled. This is super tangled. Okay. Okay, who else we got? Yeah, you're in an interesting loop right now with the alignment. It's really having to starting out with the database from 0 sucks. I don't recommend doing that. You can have some pretty high voltages across the coils. I mean, it all depends on how many turns you have, right? And what the resistance of your coils is, and how much you're trying to overcome the inductance, like how much are you overdriving it. So going almost rail to rail in your supplies across your coils is pretty common. So, I mean, almost. Let's see. Okay, so we got it opened up already. Okay, capture one. Are you done doing your thing? Are you on now? Hey, you are on. Love to see that. But actually, we're not doing that yet. We're still doing do the video first. Okay, shall we? Let's see here. Well, let's go freehand to start with. And I do not have the window big enough to be able to see what you all are saying from over here. Oh, also, Maria, welcome to the stream. Good to have you. I literally cleaned the floors. I mean, I put new polish on the floor up here like literally last night. So this is it's almost at the best it can be. I did not get the 1500 RPM 24-inch floor burnisher out to really polish it, but it's pretty clean. Okay, there's some fun things going on in here. So that is our dynamic optics driver. So at the bottom here, we've got our power that comes in. So that comes from our power supply, which we have previously had opened up and done a bunch of figuring out on. We've got some fiber optic communications going on here, most of which are not currently being used, interestingly enough. We've got a bunch of inductors there. Many components with which that we could potentially identify if we so chose. These are some fuses up there. All of these red boxes, those are all capacitors. And there's some interesting solder jobs on these capacitors, especially where they needed to increase the value. So we've got a number of different ways that extra capacitors were bodged in like that. We've also got some electrolytics spread out, so we're definitely going to want to check on those. There's X1 down here. X1 is, I think, please focus, is I think a rotary encoding switch. But I don't want to find out, because if it is a rotary encoding switch, it doesn't have an arrow on it or something for me to know what direction it's like in, so I don't want to change it. They're using a mix of standard SMD resistors and those round ones, so that's kind of interesting. All of those white boxes are relays. Let's see here, what else we got going on here? You know, oh, is that some Apex stuff up there I see? Let's get a closer look at that. Would not be surprised if we had 1 or 2 Apex modules in here, but I don't really know if that's Apex or not. Something big and wide. So yeah, this is the water cooling here. So water goes in one side, then high aspect ratio hole drilled down the length of it, then some termination feature, something that loops it back, and then another high aspect ratio hole that comes all the way down. One of the holes I think was drilled from this end, and when I was there, I think the other hole was drilled from the other end is my impression of it. I like the water cooling design on this. I also like that each of the devices, I noticed our first problem. I like that each of the devices is individually clamped. When you have multiple devices under one clamp, I just noticed our second problem. Okay, one thing at a time. Multiple devices clamped by one clamp, you end up with uneven clamping pressure on them, an issue. So first problem I noticed, this clamp here is very nearly sliding off that device. So there's the device, there's the clamp. It's all the way to one side. And it looks like there's a little bit of extra airspace on the right there. So I think, because we're clamping on one side so much, I don't think we're getting even clamping force. Is there a device on the other side here? There is. So I think I see why the clamp is like this, maybe. It's because there's that screw right there. But it... Okay, interesting. I don't like that. Okay, so another thing that's going on. What is going on? Okay, there's something else going on here. So there's two blue wires there. You see where the terminal says temp 2, right? So there's two blue wires. Let me go to manual mode. I'm going to stop my aperture down some. So we get better depth of field. So those two blue wires are a temperature sensor. The temperature sensor is underneath the spring clamp right there. It's the, like, it looks like a washer, but they put like the temperature, so I can show you this one actually. So that temperature sensor on that one is directly under the bar and it's clamped down. On this one, the temperature sensor is under one of the spring clamps that like holds down some device onto the heatsink. But that makes that stick out a lot higher. So if we look from the top here, we can see on our problematic clamp, it's actually, there's a pretty big gap there. So if I had to guess, I'm going to say that clamp, oh, that clamp's super loose, yeah. That one's a little bit loose, but like when you come down here, where it's more even clamping force all around, well, these are a little bit loose, but okay. So we want to get this one recentered. Okay, I think we need to add some stuff to the checklist or notes. So the U19 clamp, so U19 is the designation for the device that's clamped down. So the U19 clamp needs to be repositioned. The position of the thermal sensor needs to be evaluated because that might just be problematic in general. It might just not, yeah, I got questions about that. So those are the issues I noticed right there. Another issue I noticed that I haven't told you all about yet is what is going on with that. Basically, ew. What? N117 there. Yeah, what? It looks like somebody tried to clean a no clean flux maybe. So that's fun. Okay, what are y'all saying? Yeah, why does your 1455 like so screen? I don't know. It does not appear to be conformal coding. The leads look pretty nasty. I mean, what I'm seeing to me is the sign of rework, but I can't see through whatever that crap is to see what the condition of the joints look like. Okay, there's another kind of gross ones. A little bit, just a little bit. third from the left there. It's got some crap on it. Let's see here. Well, so okay, so what I found so far, it makes a more exhaustive inspection of this board tempting. So basically, we gotta decide how we want to proceed here. Do we want to just keep looking at it while it's in the microscope? Or do we want to go ahead and pull the board out of the scope and inspect her that way? Without pulling the board out of the microscope, I am unable to look at the back at all. So if we want to see the back of it, we need to pull it out. I'm seeing more signs of improper cleaning in here. So that's fun. Battlefield repair, yeah. This thing was in a fab, so it's a pretty rough life sometimes. Yeah, the challenge I'm having is it's not easy to look at everything right now, just because of where I'm at in the microscope. And all of these through-hole devices were all hand soldered in too, so there might be some less than stellar soldering that we want to address. I'm just continuing to look. Yeah, all of the through-hole stuff it's a bit grimy. I can only imagine what it looks like underneath the heatsink. I'll have to reposition to get a look up at these ones. Okay, let's just do we'll keep it simple to start with. Let's look at all the electrolytic capacitors. Let's see if those all look good. Those look good. Those look good. Those look good. Okay, then we got those three on top look good. These three look good. Okay, cool. So the electrolytics look fine at least. I like that. I'm a pretty big believer in preventative maintenance just by looking at everything very closely. It's one thing if it's my own microscope, but when I'm shipping it off to somebody, I have very high expectations for it in terms of how long it should be expected to go between needing to be fixed. And field repairs are expensive, as is downtime, so. It's more weighing that with possible issues caused by taking things apart. Especially with a big floppy board like this. This big piece of metal running down it, you know, you can pretty easily crack some stuff. Okay, I think we're gonna switch to photo taking mode. And we'll get pictures, we'll get as many board pictures as we can, and that'll kind of serve as our visual inspection because we'll be going section by section. I still want to think more about what to do about this particularly poorly cleaned device. Not super thrilled with that. It looks like they cleaned this board after they put the heatsink on. I kind of wish they would have done that before, but at the same time, you probably want all of the devices like actually clamped to the heatsink before you solder them. So I can understand how they arrived at the order of operations that they did. Just for those of you who particularly love bodges, you know, we got some good bodge wires going on down there. Let's see here, I saw a few others. Oh yeah, there's one little bodge wire down here. And then I'm pretty sure there's more. I mean, we've got these these capacitors up here. I think are pretty entertaining. They're I think those are on what were SMD pads, and they're just like, yeah, those are SMD pads, but now they have big capacitors on them. So that's even better than that one by far. Just throwing a polymer cap, film cap on a, what is that? 0806, probably 0806 pads. Oh, another bodge wire. I think. No, that was just the lighting. Yeah, I still don't feel like I've looked up in that section very well. Okay, I'm going to get the camera flipped over to photo mode here. Yeah, there is indeed some curse going on here. I would agree with you on that. Okay, let's get the camera flipped over here into photo mode. And then I got like the stream flipped over to photo mode. Okay, capture one. Why is the capture one screen capture not working? Maybe it's this? Nope, it just says it doesn't remember what it's trying to share. Okay. It is very confused, is what I've determined. It says it should be doing it. I don't know why it's not. Oh, I just have to deselect it and select it. Okay, that's cool. That's fine. Okay. Rebooting one time did not fix the front USB ports. Rebooting several times did, so that was fun. Oh. No, no, that's not what I want. I want tethered. Yeah, isn't that super encouraging? Several reboots, you know? Okay, so we don't want that one anymore. So we're going to remove that one. And we're going to... Let's see here. We want that one. So we're going to copy that one. What? It won't let me copy it. Why? Okay. Well, I don't know why it won't let me copy it, but that's fine. Well, that's one way to get it back. Oh, I've lost it off the side. Okay, how do I get that back? Okay. Man, updating the OS really just changes everything, just enough to be annoying. Like, OBS does not remember any of what I want it to do or how I want it to do it. Okay, that should do what I want it to do, I think. So theoretically, if I take a picture now, hey, there we go. That seems like it's working properly. So we're doing high dynamic range shooting. So it's going to be 3 pictures per exposure, and then it stacks those, or three different pictures, 3 different exposures, and then it stacks those so that we get as much detail. But the HDR shooting does make the automatically selecting the next picture to go to thing behave really weird sometimes, every time. So that's just going to continue to be a thing. Cool. Come on. So we're starting to kind of getting some pictures of our connectors. And we'll do just some kind of standard board photos without really focusing on anything in particular that's wrong yet. It's gonna be hard to get good board pictures all the way down this end here because of our just the angle we're at. At least there's not very much going on down at this far end here. Trying to focus on the capacitors. I don't think I quite got that. Or the, sorry, not the capacitors, the fuses. There we go. Definitely want to know what all my fuse values are. Okay, what's the value on these polymer caps? $4.7. Is that not an M, it's a micro, right? Yeah, that's microfarads. Let's take a picture of another one. Why aren't you letting me release a shutter when it's not in focus? I know it's a setting. Okay, manual focus. Yep, UF, okay. Cool, glad we got that squared away. Okay, let's make sure we get the value on these caps. Okay, so let's get pictures of what's going on our rail, and then I think that'll be good for this top half here. And I'll figure out too about the bottom half, because I still don't know how to access that very comfortably, for me at least. This picture here shows what's going on with those blue wires, which is that thermal sensor. Temp 1. Oh, then let's make sure we get a picture of this bodge, right? That's important. The 0806 through hole. Okay, so that's our top half done. Let's take a look at what we got going on down here. See if we can't light that up better. So what do we feel about the FPGA choice? Or how do we feel about the FPGA choice? That's a Xilinx XC95216. I think that's the number that matters. Once again, that is XC95216. Oh, look, a RAM chip. Probably should harvest that. Might be worth more than the whole microscope. Okay. There's also a chip over here that has Inficon, Bosch, and Siemens branding on it all at the same time. That's great. It's a CPLD. Oh, okay. Okay. So what's this one? That is a SAB-C167CR-LM. Is it really from 1995? I mean, yeah, given we got Siemens, Bosch, and Infineon branding on it. I said Inficon earlier. That was a slip of the tongue. That's funny. Got vacuum on the mind. It wouldn't be, truly it wouldn't be an electron microscope without some goofy chip selections, right?
Asking the hardware and software engineers of electromechanics who hurt you is a valid strategy towards understanding the design decisions that were made.
Glad there's a place on the board that says test serial number and test label, and doesn't have either of those. So I guess they just stopped putting the serial numbers up there. Okay, the serial number's down here.
Actually, you can just barely make it out, but there's a separation in the ground planes over here. It looks like this is a 4-layer board. Okay. I like that we have a bootstrap jumper. That's fun. Wonder why we have that separate ground plane over there. I mean, it looks like it's more analog stuff over there. So I guess that makes sense. Yeah, I see on the left side of the FPGA, it seems like there's another ground plane separation. No, sorry, CPLD. Interesting.
What's up with what in particular, Monochroma? So here's another chip question for y'all. What is this thing? Let's say...
This is the one that's kind of
not been cleaned very well, we'll say. 06AHNLM. And then another number on it is a TL084C. And it's a Texas Instruments part. Once again, that's 06AHNLM. TL084C. That the designers always put a spot for it and no one uses it? Yeah. It's a mood.
High-speed JFET input quad op amps. Okay, that's cool. Probably don't want it to be dirty like that. I don't really know how the best way of gonna clean it in situ is, but we'll figure something out. So that's pretty much our pictures of this board. If we're not going to pull it out. Okay, we got more evidence of rework right here, actually, I just noticed. So this bodge right here with these two caps, you can see where the caps are glued to a chip on the top left corner there. They actually just straight up glued it to a chip. That's amazing. And they shipped it like that for who knows how long. Because as we all know, it's completely impossible to revise a PCB. Completely impossible to revise a PCB. Way too much trouble, clearly. Okay. So now we get to decide what we want to do about, well, we got a couple of decisions we need to make. We need to decide what we want to do about cleaning those areas that are a bit dirty, especially that one chip. I might go at that with some swabs and some ethanol. We also got to think about what we want to do on that one device that's not being clamped to the heatsink particularly well, and also what the kind of weird uneven clamping force thing going on with our thermal sensor. Okay, so I'm just pushing on the thermal sensors just to see if they move at all. And they're, I can't push on the one on the left. I can push on the clamp that's on it though. Okay, so those are not moving. So the thermal sensors are at least held down pretty well. Okay, so let's see here. I'm gonna work on that one device that's halfway clamped on right now. I want to get that not tipping over the way that it is. Oh, we lost a camera. Yeah, I gotta be careful about changing out bad sensors, right? That'd be bad. Out of curiosity, are we getting the slideshow issue where the update rate is really low? Because we're doing I'm getting encoder overloaded warnings. We are, okay, that's because we're screen sharing. Is it happening constantly? Like, is it happening right now, or is it just happening like when I'm actively taking pictures? The stream died for a second. I don't think that was on my end. YouTube says my stream is healthy. What? I'm in a loop. Okay, let's just go off of capture one. Okay, how about now? Are we still getting weird issues now? Oh, okay. Okay, now I'm getting some stream house stuff. YouTube is not receiving enough video to maintain streaming. As such, users will experience buffering. Oh yeah, it's real bad. Okay. Yeah, we're struggling. And the stream, it's still overloaded. Why is that? Okay, maybe this helps. Coding overloaded again. That seems like it helped, right? No, it's still stuttering some. Let me try disabling something. I have a source record filter for my screen cap, but I don't really need that, so let's try turning that off.
Okay, how's that? Did that help maybe? Okay, that seems like it helped, and I'm not going to need the encoder overload it anymore. It is also unnecessarily recording my iPhone. Okay, sorry it's a black screen for a second. Okay, I turned off another one of the source records. Okay, I think that should work now. Let's hope that fixes it. Okay, let's take some notes on this. What did we notice? Oh, we're back to stuttering, aren't we? Why? What are we doing? Okay, OBS is lying about my CPU utilization. It is completely pegged across all of my cores. Okay. Suboptimal. I'm not. Okay, I just closed Capture One. Let's see if that resolves any of my CPU utilization. Absolutely not. Okay, we are still using well, okay, there we go. Okay, it's dropping off now. Okay. So that's my CPU utilization right there. So you can see when I closed Capture One, things became not completely pegged. So hopefully that explains what was going on. But I wasn't doing anything to Capture One. Like it was just, Capture One was just sitting there. Oh, I was doing preview processing. Capture One is doing preview processing, and that is very good at saturating all of the CPU cores. That's what was happening. Okay, mystery solved. I need, okay, what I need, yeah, I need a separate computer to be doing the photography with. I think that is the solution. Okay. Let's take some notes. What were my chip designations? I would look at the pictures in Capture One, but Capture One and Stream don't like. So N117 is the really contaminated one, and U19 is the one that's not clamped properly. N11Y, no, N117. Yeah, pretty much. And then, what was that, E17? Oh. U19. Okay. What else did we notice? So we've got the N117 contamination, U19. Okay, so we got the temperature sensor, we got that. I'm going to do something that's a bad idea, and I'm going to open up Capture One again to review everything that we documented. So this is going to likely make the stream hang a little bit. Sorry in advance. Maybe I can actually do something. Let me try.
Okay, yep, we got encoded overloading again. I'm seeing if I can make this less bad. Oh, it's only generated 20 out of 104 previews. Okay. 22, 24. Well, it's moving pretty fast. I don't know why. Oh, no, now it's not. Why would it? I didn't take pictures that quickly. You think it'd be able to keep up? Huh. Okay. Sorry about the stream being laggy for a little bit here. I'm just gonna let that finish processing. I think, yeah. But I am gonna drop the preview resolution down. Oh, that sped that up a lot. Okay. I sped that up a lot. Okay, cool. Doesn't help you all yet, but it will get us through the encoding overloaded faster. So we're gonna go with that. So this is already opened up. So we're gonna take those off. So we've done this now. Okay, we're 71 out of 104 previews generated, so you should be back to a normal frame rate on the stream soon. Frame rate's been good recently. Okay. Well, that's impressive because my CPU performance on every core is saturated. Including putting 10 UF polymer caps on 0806 SMD pads and gluing caps to other caps for support. Other caps or chips. Okay, so it finished generating previews, so we should be pretty good now. Yeah, cool. Previews are generated. Okay, let's look through these a little bit more, see what else we got going on. Anything else interesting?
I should have had you all taking notes for me while I was down there, so I don't have to go back and do my notes now. I do think we're gonna be wrapping the stream up here soon. I think we're gonna pick up next time with pulling the rail off to get access to all of the clamps, so we can readjust those. But I'm just gonna wrap up right now with taking notes on what we got. I'm, trying to stream earlier, so gonna have a busy week next week too. Busy streaming, so we'll be plan right now is basically be working this thing every day next week, and we're pretty confident I'm gonna have this thing in bake out next week, so that's gonna be exciting. But I know it's not even midnight. My UK viewers are going to be disappointed they missed out. We might be starting early enough tomorrow that they could join at the start of their day, or at the end of their day instead of the start of their day. So nothing as concerning as what was around and 117. You should be able to see it on typing, right? Or, oh, okay. Or, oh, I see. I'm too far down the page. Okay. Well, I'm just gonna finish this one line then, and then we're gonna wrap this up. Basically, I'm just talking about right now how like it seems like the PCB is cleaned after that heatsink was installed, and that's not great, especially because the PCB is like right up against the heatsink, so you got that like long trapped area underneath it, and then you're also gonna have kind of some like water or cleaner just like trapped underneath the thermal pad everywhere, because there's like one big thermal pad for all the devices. Okay, well, I got my notes wrapped up here, so I think with that, we're gonna go to wrap the stream up. Thank you everybody for joining. Thank you, Greg. Thank you, Monochroma. Thank you, a YouTube channel, 2065. Thank you, W6EL. Thank you, Maria. Thank you, everyone who joined along for the night. I look forward to seeing you all tomorrow when we pick up with working on that clamp that's not quite clamping right, because I've seen so many device failures on microscopes on the water-cooled heat sinks with the caused by clamping issues. Like you get devices that aren't fully clamped to the heat sink, device gets hot, device dies, kills a bunch of other stuff on the board. We don't want to see that happen to this one. So yeah, that's the plan. I'll see you tomorrow, and yeah, you all have a good one. Bye.